Good morning and welcome you all for today's class. Today we are going to discuss to find out what is center of pressure and pressure force acting on the inclined submerged surface. And in previous class we have discussed how we can calculate center of pressure for the vertically submerged surface. Here this is a more convenient way to find out pressure force and center of pressure for the inclined plane. Once you know inclined plane and what is center of pressure, then you can find out center of pressure and pressure force for the vertically submerged surface. This one is a most important case of the pressure, center of pressure, finding out center of pressure and pressure force for all submerged surface, because in most of the cases in dams and sluice gates, there are so many applications where we have to design dam walls which are mostly inclined. We have to design gates and windows which are submerged under the water, and you can see when submarine is under the water, there are pressure acting on the curved surface. So there are so many applications where object is under the water, under the liquid, and we have to find out pressure. And this surface, most of the case, it is not in vertical position, but in inclined position. And the shape of the surface may be rectangular, maybe circular, maybe partially rectangular. So many cases are possible, but here we have to derive general equation for the finding out center of pressure and pressure force acting on the submerged surface. So first we draw a drawing and then we calculate how to find out. So let us start now. First we draw a plane. This is a liquid surface and this is a liquid surface, and this plane is inclined at alpha angle, and we have to draw a surface that is a reference surface that is perpendicular to this inclined surface. So this one is a perpendicular surface, O dash, and let us make a surface. If it is a surface and projection of this surface, you can see cut a small strip of this surface. This surface area is A, and cut a small strip of this surface. This is a small surface area dA. That is a dA, and here you can take this. This is a surface that is inclined alpha with the free surface, and this one reference axis which is perpendicular to inclined surface. And if it is projection, this we can visualize here. When we see perpendicular to this surface, we see that is a shape of the surface. This is a shape of the surface, and we take a small strip of dA and take here, extend these lines up to here. This line will extend up to here, and this strip vertically having distance y from the free surface, and this one is center of area. This is center of area. Center whole of the area is concentrated at this one, because every shape, everybody has when it is in surface form, has a point where whole of the area can be assumed concentrated. This is center of area. So center of area, we take a line here and extend this line here up to this one. So this one will be equal to y, this one will be equal to yc, and there will be center of pressure Cp, and this point we take here. Corresponding distance from the reference line is L, and this will be equal to LC, and this will be equal to LP. These are corresponding distance from the reference surface. So, and corresponding distance from this vertical surface from free surface will be equal to yp. So yp is a vertical distance from the free surface to the center of pressure, and yc is a vertical distance from free surface to the center of area, and y is a vertical distance to the area taken arbitrarily, means vertical distance of this area. This is a surface, and we are showing here for the clarification that this is a shape of the area. So first we define by using a pressure relationship. What is the pressure at this point? What is pressure on this strip? So P can be defined as pressure on the strip, pressure at distance y, means P equal to omega y. By simple equation, P equal to rho gh, and omega equal to rho G, and rho is density of water. Suppose it is a submerged. This surface is submerged in water, or you can say density of liquid, and G is a gravitational acceleration. So P equal to omega y. Instead of adding two symbols, we use only one symbol for simplicity. So P equal to omega y. Due to this pressure, what is the force acting on this? We have taken a small elemental area dA. So what is a force? That will be a small elemental force acting on area dA. dF equal to P into dA. That is equal to omega y dA. Omega y dA. You can write omega because y can be written in terms of the length L. This is a length L. This is a length L, and this one is a length LC, perpendicular distance of reference, and this will be length LP. So we can write omega L sine alpha into dA. Which is a force, elemental force acting on the elemental area dA. Now total force acting on the whole of the area. So we can integrate this dF force. Total force due to pressure, varying pressure at different points. Because as we go down, depth will be, because pressure is proportional to depth of the depth from the free surface. So once y increase, pressure will also increase. Total pressure will be integration of this. Total force equal to integration of dF for whole of the area. That is equal to omega is a constant, sine alpha is again constant. We will integrate LdA for whole of the area. You know that L into dA for whole of the area is the first moment of area. If it is a first moment of area, this quantity is first moment of area, that will be equal to omega sine alpha and LC into A. LC means a distance from a reference line to the center of area. According to definition of first moment of area, LdA, integration of LdA for whole area equal to LC into A. Now omega, you see that LC sin alpha equal to YC. From equation you can see LC sin alpha equal to YC, because YC upon LC equal to sin alpha. So LC sin alpha, YC equal to LC sin alpha. So LC sin alpha equal to YC. You can write omega YC into A. Whole force is equal to omega YC into A. Here sin alpha is missing. There is no any value of sin alpha. So it is a force, pressure force acting on the submerged surface is independent of the inclination angle. It does not depend upon the inclination. Only depend upon the YC, because omega is constant, area of this area is also constant. So only depend upon what is the depth of center of area from the free surface. Only dependable parameter is YC, not depending upon the alpha. Whatsoever inclination it may be, pressure force acting on the submerged surface is independent of alpha. So this is a force that we can calculate by using this equation. So now reducing the size. So now see, we have calculated YC. F equal to total force, F equal to omega and YCA. So you question number 1. But we know that this force is not acting at the center of area, because this pressure force is not acting, because pressure is increasing. If you draw the diagram here, pressure force is varying. Pressure force is varying like this. Here more pressure, here more pressure. And so center of pressure is not a center of area. It is not a centroid of this area, but it is lying somewhere. This is a point where center of pressure acting. Center of pressure can be defined as a point on the area where whole of the pressure force is acting. Due to pressure force is acting on the surface, and that action point is known as center of pressure, because it is certainly for the vertical surface or for the inclined surface, it is not acting on the centroid of the area, but away from the centroid area, below the centroid area, always below the centroid area, which is a vertical surface or inclined surface. So we can find out by taking moment. What will be moment of this force with respect to center of pressure? Taking moment of this force with respect to center of pressure from reference axis O dash. We are taking moment of this force that is acting as center of pressure from the reference axis O dash. That moment will be equal to F into LP. That is equal to omega YC and YCA into LP. This is equation number 2. If it is a whole moment of this pressure force with respect to axis O dash. Same thing we can calculate by using a component of forces. And we have already defined component of forces DF. DF equal to omega L sin alpha to dA. This is a component of force because there are so many forces acting on different strip. Because this elemental strip, there are so many elemental strip. Infinite number of elemental strip are there. If you take moment of all these strips, these forces with respect to O dash, we can find same thing that we calculate for the whole of the force. This is a force acting on the elemental area. So take moment of this force with respect to O dash. Take moment of this force with respect to reference axis O dash. That moment, taking moment of force DF with respect to O dash. O dash means reference axis. That is equal to omega L square sin alpha into dA. This is a small moment. And taking moment of all component forces, taking moment of sum of all component forces, that will equal this one. Moment of all component forces with respect to O dash. That will be equal to integration of this equation. That will be equal to omega L square sin alpha dA. That is equal to omega sin alpha L square dA. And this is second moment of area. If it is second moment of area, that can be defined as omega sin alpha into I naught. Because I naught, it means moment of area with respect to O dash. Moment of whole of the area with respect to O dash means moment of all component forces with respect to O dash. Omega sin alpha into I naught. Already we have calculated by using first principle, that is omega YC into LP. From equation, this is equation number 3. From equation 2 and 3, equating because both are same. We have taken moment of whole force with respect to center of pressure, and by using component forces and integrating for whole of the surface, we get same moment of force with respect to O dash. So both are equal. Equation 2 from equation 2 and 3. From equation 2 and 3. From equation 2 and 3, both are equal. So omega YC LP into A equal to omega sin alpha into I naught. Now omega can be removed here and replacing this one. So now remaining question YC and LP into A equal to sin alpha I naught sin alpha into I naught. And we can break I naught with moment of area with respect to O dash, moment of whole of area with respect to O dash. So this can be written as YC LP, and LP from this equation you can see LP. I think it is something erased here. So we can extend this line to this one. So LP equal to YP upon sin alpha, because YP equal to LP sin alpha. So LP equal to YP upon sin. From here you can LP equal to YP upon sin alpha. Yp upon Lp equal to sin alpha. So Lp equal to Yp upon sin alpha. You can write here Yp upon sin alpha into A equal to sin alpha into I naught can be broken by using parallel axis theorem, that is equal to Ic plus area into LC square. Now Yp into A equal to sin square alpha Ic plus A. Now LC again we break in terms of Yc upon sin alpha. So LC equal to Yc upon sin alpha. From this figure you can see LC Yc upon LC equal to sin alpha. So LC equal to Yc upon sin alpha, that is a Yc square upon sin square alpha. Multiplying this, so we get Ic sin square alpha plus A Yc square. Now dividing Yc by Yca, so we can find Yp equal to Ic sin square alpha upon A Yc plus A Yc square upon A Yc can be removed. So Yp equal to Ic sin square alpha upon A Yc plus Yc. This is the equation for the submerged inclined plane. Now you can, by using this equation, we can derive other cases. By using this equation, we can derive other cases also. Let us see case 1. Case 1, alpha equal to 0. When alpha equal to 0, it is just horizontally. Plane will be horizontal, means parallel to the free surface. Plane will be parallel to the free surface. So alpha equals 0. Then that case, this term will become 0. So Yp equal to 0 plus Yc means Yp equal to Yc. In case of plane surface, it is not inclined with the vertical surface, with the free surface. Means both are free surface and plane surface are parallel. So alpha equal to 0 means Yp, center of pressure and the center of area, means centroid of the area, both will be same. Both distance on free surface will be same. Means center of pressure and center of the centroid of the area, both will be at the same distance on the free surface. Means Yp equal to Y. Case second, alpha equal to 90 degree. Means vertically, means surface is vertically inclined 90 degree. Means 90 degree from the free surface. Plane is 90 degree from the free surface, like this. 90 degree from free surface, like this. This is a vertically inclined surface. This is a free surface, and plane is vertically inclined like this. In that case, alpha will be 90 degree. So Yp putting means Yp equal to sin square alpha equal to 1 Ic upon A Yc plus Yp. This is a case of vertically submerged. So all cases can be derived or determined for the submerged surfaces. So this question, one question are always there. You will find in competitive examination or academic engineering examination subject for subject fluid mechanics. Both common for the mechanical engineering and civil engineering. More important for civil engineering because they are more involved for the design of the dams, different types of curved surfaces under the water, where we have to find out the center of pressure and forces acting on the curved surfaces. This is the most important. But one in this equation you can see what are terms there. Ic means moment of area that we have to find by using, because different shapes have different moment of area about the centroid, and Yc means vertical distance of the centroid from the free surface of the water or liquid. And once you get Yc and once you get Ic, then everything will be clear. Alpha will be given in a question, inclination will be given. So this question become easy for you once you know how to calculate moment of inertia of area. Second, moment of area for given shape of the, because shape may be circular, semicircular, or triangular, or different trapezoidal shape may be there, maybe hollow surface may be there. There is a trapezoidal surface and maybe hollow inside surface. So for all these cases, in your engineering mechanics, already you have all familiar with the finding out moment of inertia of area for different type of shapes. Once you revise this, then this will become very easy to solve such kind of questions. In our next lecture, we will solve some questions so that you can become familiar how to tackle the question. Thank you very much, and I hope that this is sufficient, and you will like and subscribe and share to your friends. That will motivate me to make videos on important topics continuously. Thank you very much, and have a nice day.